Steam Bending Workshop Part 1 Theory. Hi folks, this is Otto. I'm managing partner at GHE Bavaria, a company that supplies steam bending solid wood equipment to the wood industry. In other words, what we are talking about is not like a pro. No, we are the suppliers of industrial customers all over the world when it comes to steam bending. Volumes like bend parts for 1,000 chairs per 8-hour shift and such kind of things. Even many of the old Thonets and IKEAs use our gear. And I wrote my doctor's thesis on this matter. So we think we have at least some basic idea what's it all about. And in this series of videos, we will try to share at least some of the secrets and the black magic behind it. Wood is bent for thousands of years. Imagine all the wooden boats and ship hulls they were producing since the old days when the ancient Egyptians started to construct their sailboats. And later, when people started to make oak barrels for the storage of wine and beer. But for bending chair frames and things, Michael Thonet, a German cabinet maker, went to Vienna to produce chairs and other furniture for Vienna manor houses. After all those trial and error processes he went through, after all the cracks, always on the outside of the bending, Thonet tried to suppress the outside extension by the use of a metal strap with end stops when bending. He finally succeeded. And that's why today it's called the Thonet Method, when bending steamed wood with an outside strap to block the extension of wood while bending. What it takes is a bending strap with 2 end stops, a piece of hardwood that fits exactly into that strap, a softening device, such as a steam box or an autoclave, a die, a table, and some clamps when bending manually, or with a machine for the production of larger volumes of bent parts, and eventually a hook to finally fix the part. At this point, I would like to invite you to subscribe this channel if you should not have done it earlier. Now, in today's world, there are loads of books and papers that describe what's happening when bending wood. The tensions, the densification zone in the part that increases radial from outside to inside and that increases with a bending factor S equals inside radius R over thickness T. In industrial production, we try to keep the factor above 3. In other words, for a 30 millimeter thick part, the inside radius should not be less than 90 millimeters, or if calculating in imperials, for example, a 1-inch part should not be bent with a radius of less than 3 inches. Certainly, you can bend closer parts, such as 60 millimeter thick with an inside radius of 60 millimeters, or some 2-inch thick with a radius of the same size. The thing is that in this case, it's absolutely necessary that everything is absolutely okay. That means no knots, absolutely even parts, appropriate initial moisture content, machine moving with a very steady speed and things. Then there is a good chance to get nice okay parts, otherwise there will be ripples on the part. And if one has a knot, all parts that are bent together in the same strap will be damaged in this particular case. The other phenomena that can be better understood when thinking about the whole process is the third phase of the steam bending, the stabilization. There, a transition of viscoelastic to viscoplastic behavior can be monitored. In other words, the until then elastic part freezes. It's easy to understand why a fine bent part cracks if you remove it right after bending from its step with the 2 end stops. The internal tension still exists, still trying to fight the densification, and as a result, the inside of the part still being elastic pulls it apart and simply cracks the part by doing so. Just a problem of having opened the strap too soon. Nothing else. If waiting a little bit longer after bending, approximately 30 to 60 minutes, having the part cool down and literally having frozen most of the tensions, this will no longer happen. That's what you see at the end of this line. There are books about steam bending or solid wood bending if you want. Personally, I think the Wood Bending Handbook by Stevens and Turner is really a substantial, good entry for both professionals and home pros. It's describing you a lot of tricks and treats, really giving you ideas of things to be tried. There's a table with bending properties of a wide range of wood species too. We at GHE Bavaria managed to put some of these boundaries a little further, probably because of having better equipment some 50 plus years later. No matter, still a really fine book. The next source would be the homepage of our company, GHE Bavaria, where there is a download section with loads of presentations, papers, and even a wrap-up of my thesis. The link is below. Please help yourself. And then, if you want to have a huge compendium of wood science and technology, it would be the 2023 Springer Handbook. It covers basically everything related to wood properties, woodworking and machining. It's just a little academic, using a lot of scientific language, but it's great. Please believe me. Still, I think Stevens and Turner's Wood Bending Handbook covers all the know-how you need to know to do steam bending or solid wood bending. No more trial and error. I haven't seen the latest edition so far, but in my older one, they do not suggest to use fabric softener to support steam softening of wood, and nor do we. Our steamers are simply powerful enough to soften the wood without chemicals. Thonet didn't use fabric softener, and none of our customers would add fabric softener to soak or steaming wood for bending. I mentioned this because on one of the videos on YouTube, the protagonist says, "I use the fabric softener because I saw it in more than 2 videos on YouTube, so I understand that's what it is." Well, no, definitely none of our industrial wood bending customers uses fabric softener for softening wood. And I haven't read about it in any CS book. Just water is fine. Still, if you have a specific question, write a comment below and one of our team will answer. The next part of this workshop will cover the most important step of the whole process, the steaming phase. You will see how our gear looks like: big autoclaves, the compact steamers, and the occasionally used steam box that is so different from what you see on YouTube in many videos. We use it for soaking and sometimes even for steaming. We will disclose how we check water absorption prior to steaming and moisture content after steam and things and everything. So please stay tuned. Looking forward. See you again then. Bye.